Another one from Paul. I so wish you would give me the exam year and paper because the pictures she takes are very sketchy and I can barely see them. They're all out of focus. So she wants to answer this one, and I think her main problem is this table. Right, there's the splitting pattern, obviously. All right, suggest why this guy, and I think that's the solvent and not this I used. Well, if we use this one contains a proton and it will interfere, won't it? Interfere with the spectrum because it's got a proton in. This one has a deuterium atom in, deuterium atom, and these won't interfere. So we use this as a solvent, CdCl3. All right. Interestingly, this one's CHCl3 and CdCl3. They're known as chloroform. Okay, and the CdCl3 is known as deuteriated chloroform because it's got a deuterium in. All right. Now, just I don't know if you can read this. Use the data booklet and the spectrum to complete the table. I think it says for the proton NMR structure of this pentacane. The actual chemical shifts for the four absorptions have been shown. All right. So these are for this is 7.4 or so. This one is 5.5, I think. This is 3.5 and this is 1.2, I guess. First of all, what I can say about this is you've got a classic CH3CH2, okay, and that is classic. The CH2 is next to 3, so that will be a quartet, and the CH3 is next to 2, that will be a triplet. So this one here, the group responsible for this is the CH3 group at the end. Okay, number of protons responsible for the that's going to be 3, and the splitting pattern is known as a triplets because it's in 3. This one here, now we're looking at this one. This is the CH2. The number of protons are 2, and this is known as a quartet. 5.5 is this one. Well, it's a singlet, isn't it? And the only singlet I can see the NH2 protons. So this is going to be NH2. There's 2 protons, and that is a singlet. Okay. And the last one, this funny mess here, is these protons here, the ones in the benzene ring. Now, benzene NMRs, the protons in benzene are very mysterious. Okay, but they do interfere with each other. So you do get a splitting pattern. All right, so it's the multiplet. There's the benzene protons. Okay, and there are 4 of them. Okay, even though it doesn't look very good, does it? But that's it. Okay, now Lompo said something. I must admit, I didn't quite understand what she was saying. Let me finish the question first. Explain the splitting pattern for the absorption at, was that 1.2, I think? Is it 1.2? Yeah. Well, that's split into a triplet because it's next to a CH2. All right, so you get the n plus 1 rule. It's next to 2 protons, so it's split into 3. All right. Now, someone mentioned that she got confused at the end here. I don't know why. Perhaps someone can get back to me because I don't quite understand the problem, but it's quite a straightforward one, really. All right, thank you.